Welcome back, everyone. Today we're going to be talking about lists and sets. So last week we talked about variables, which is our first data container, something that holds a single piece of information. Now we're talking about lists and sets where we can put multiple pieces of information in them. Before we get started, let's talk about some of the key concepts from the first week. Okay. These concepts include the data types that we're starting to learn. So we have integers, strings, and floats. So floats and integers are numerical values. Strings are alphanumerical, right? So they include letters and numbers, and so they are kind of set off by quotation marks. We'll see that here in a second. And then we also have our basic data types, or our basic data structure, or basic data containers, right? And all we talked about was variables. That was creating or using a data container name equals, and then what information we want to put inside that data container. So it was a single variable and creating information. So let's see some examples. So here we have a couple of examples. This first one is a string value, right? You can tell it's a string. Why? Because it's orange, but also because we have the variable name, okay, and no spaces. Again, if you put a space, it's going to freak out, right? No spaces. I can use underscore, I can use anything like that, but no spaces. And our string is marked off or indicated by quotation marks, okay? If you have quotation marks, it's going to be a string. And then I can annotate this, which we talked about also, with things like, with a hashtag, this is a string value, okay? And then we have here an integer, okay? It's actually, let's make it less big. We have an integer right here, okay? We've, again, marked it off with our variable name. And here we have a float, okay? And you can tell as I hover over it, it's telling me actually what each of the variable types are. So this one's a string, you can see str. This one is an integer, int, and this one is a float right there. Okay, and we also talked about methods that we can apply to the different types of data. So here we have a uppercase method. So we put in our data name, our variable name, data container name, dot upper, and then our additional parameters. For uppercase, we don't need that, right? We need it for split. Okay, so here we've done we've done a string method here. It is called split, and what we're doing is splitting on the space up here. Okay, we'll run this real quick, and you can see that we have, and then down here we have printing of this mathematical function, and then we have the printing of our split method and our printing of our uppercase method. You'll notice with the split method that we get this value that is marked off by brackets. Okay, what we've done is created a list. Okay, this is a list of data points that is now what is contained inside IA240. Oh, it's not contained because we didn't put it in. If I was to put it, say, instead, say I241 is equal to this, then IA241 is now a list instead of a string. Okay, so data basically said it's in there, and then I changed the data and overrode the first variable, and then I printed it. Some things to keep note that don't work. Okay, we can't just do mathematical functions without telling it to do something else, right? So I'm not creating a new variable with this information. I'm not printing it out. It exists, but I'm not going to see anything. Here, same thing. I've created a new variable with 242 as the variable name, but I'm not actually telling it to do anything. So both of these things are happening virtually. They all exist out there, but you're not going to see any results. So if you ever see like, oh, hey, I ran this, I'm not getting anything out of this, just double check to see if you're actually printing it so it shows up on the output, or if you've sent it into a new variable. So I can say that, you know, this variable actually exists, IA242, and it's right there. You'll also notice that if I put P, does it run? No. P is not, print with a capital P is not defined. It's always lowercase. Okay, and so these are tricks and things that you'll notice as you come along, that all of our functions are going to be lowercase. It's not until later that we'll find something that is uppercase, and we'll talk about that then. Okay, so those are the big concepts from the first week. Let's talk about lists and sets a little bit. Okay, so here we have our basic data types: strings, integers, and floats, variables, and then you see lists and then sets on here too. Next week we'll talk about dictionaries and tuples. So how do we indicate that we are dealing with a list or set or a tuple or a dictionary? Okay, so you'll notice on here lists, tuples, and dictionaries, or sorry, list, tuples, and sets are all collections of values. Okay, it is all going to be a collection of numbers or strings that go together into one data container, and they're marked off by different things. Okay, here we have symbols. For list is a bracket, for a tuple is going to be parentheses, and for sets is going to be braces, which is the same as dictionaries, but dictionaries takes a different structure on the inside, so Python knows the difference. Okay, lists are ordered. Okay, the order matters. Okay, so what we mean by that is that how I put things in the list matters for how I reference things. Okay, so if I have a list of all of your names in my list data container, I can reference different names in that data container by the positions that those names have. Okay, so I can still sort it and do all the things, but the order there matters, and that's helpful, and you'll see why here in a moment. In sets, though, the values are all unique. Okay, and so if I have if my lists contain lots of duplicate values, I'll show you an example here to provide some context as well. But if I have a list that has a lot of unique values, if I change it into a set, it's going to use just the unique values. Okay, so let's say I have a list of the top scores in the NBA over the last 30 years, right? There are going to be duplicates, right? And so if I make it a set, it's only going to have, instead of 30 names, it might have, say, 15 or 20. I actually haven't looked. It's probably going to be closer to 15. Okay? So let's talk about definitions for each of these. So a list is a sequence of values in a particular order. Okay? The order matters, but the order can change. Okay, why is this important? Is because we are going to use something called an index. And an index is going to tell us the position of each of the values in the list. Okay, so we can change things, we can modify things based on the position of things in that list. Okay, we're going to create lists by using brackets. You can also use the list function, which I don't use as much, but we might use it in some of our loops and other things later on. We can use it to store basically, maybe not anything, but a lot of different things. We can use it to store strings, numbers, other variables, and other lists. Okay, and then you become what's called nested lists, right? So I can have a list of, say, all of the NBA players, and then I can have a list of all of the owners or GMs or coaches. I can have a list, so I can build in different lists together if it's appropriate. And lists are mutable. What we mean there is that we can change things out. Okay, when we deal with tuples, we can't actually change data in. Once the data's in, it doesn't change. But we can change lists. So for example, in our class, if I have a list of all of the students and someone else joins the program or joins the class, the list of students can change. Okay, I can add a new student, or I can take a student out, those sorts of things. Okay, so let's just, before I move on to indexing, let's just look at a list. Okay, I'm going to make a quick list. I'm just going to say attendees list is equal to, and I'm going to say Mike, Paul, Susan, Alice, Mike, Paul, James, Theodore, Abigail, and now I'm going to go back and add in quotation marks because all of these are string values. I should have been doing that all along, but I didn't. So rather than have this thing hate me, we're going to add that in now. So what are some of the things you notice as I add these things in? Well, one, you can notice the color changes, right? Oop, should not have run it. You'll notice the color changes, right? So as I put one in, it thinks that this from here to here is a string. Okay, and so it's kind of messing up. It's got an uneven number of strings. Another thing you'll notice is the color of the commas changes, right? Because it doesn't know which one are strings, but once it has an evenly matched number of pairs of quotation marks, right? What happens is that the commas turn back to white. That's useful because it can help us help tell us if we're missing a quotation mark, where's the mistake? If all of these are orange and this is white, we've made a mistake somewhere. We need to adjust that. Okay, and then let's go ahead and print our attendees list. Okay, and you'll notice that we have all of these people's names in here, right? But I could also add in other things. 2 is equal to, let's say, we'll take all of this, copy it down here, comma, 1, 2, 3, 1, 2, 4, and then we'll put in another list of, let's say, Bob and, I don't know, Phil. Nope. Phil. And then we'll close off our list again. Okay. And then we can print out these lists too. And so what I've done here is, so we have a normal just list that has string values. Okay. And then we also have a list that has string values, but then also floats and integers and another list. Okay. So we can put any types of data in here that we like. It's just going to be a matter of keeping it organized and understanding what you're looking at. Okay. Which brings us to the second thing I want to touch upon with regards to lists. So like I mentioned, list indexes are important. Okay. We can access any item in our list by telling Python the position or the index at which the item is. And one thing to note with lists is that the first item is always 0. Okay. So anytime you put something in a list, starts at 0. So if I want to reference the first thing in my list, I have to type in 0. Okay? And so if I want to make a slice, or if I want to print something specifically from the list, or make a combination of a smaller list that comes from the bigger list, if I want to slice it, I need to specify where my first item is and where my last item is. Okay? Let's take a look at that. So here I have printed out from the attendees list in the index of the 0 position. So we use the index, or you can use this indexing by using the brackets after your variable name. So we put my data container and then I use the brackets to specify what item in there I want. And it's going to print out the first. So if we look at attendees list, Mike is the first. If I change this to 1, it is going to be Paul. If I change this to -1, it is going to be the last person in the list, Abigail. Okay. I can also print out a range. So I can say 0 to 4. And what you'll notice is I get 0, 1, 2, 3. Okay. So it's not 4, it's not inclusive. Okay. So if you want to print out to be inclusive, you have to go one more. Okay. So we print out 4 items, and that is all we're going to get is 4 items. It's going to stop 0, 1, 2, 3. 3 is the last one. Okay, so it's kind of confusing. It's something to watch out about. Make sure you're getting all of the things. 0 is always the start, and the endpoint is non-inclusive. So you have to make sure that if you want to go to the second Alice, you go one more, okay? Other things that you can do is that you don't have to have a endpoint. So if you want to say print the last 3 or last, I don't know, we'll just do 5. Is that you can leave it empty and it's going to print from number 5. So 0, 1, 2, 3, 4, 5. And it's going to print all of the ones after that. Okay, and we'll get some practice with this week as well. The other thing to do is to use what's called splicing, and instead of printing, what I've done here is I've said take the variable or data container attendees list and give me the first 4 items in that list and put it into this other data container. And so now I have another data container called attendees list small, and that only has these 4 items in it. Okay, and so I mean we can change this around too. We could say give me items 2 through 6. Okay, and so items 2 is going to be 0, 1, 2. Okay, and then 3, 4, 5, 6 is right here. And so 6 is the non-inclusive. So we're doing 0, 1, 2, Susan. 3, 4, 5, 6 is here, so we're stopping at Mike. Okay, and that's what we have right here. Susan, 2 Alice's, and Mike. Just like with strings, we're going to have lots of methods that we can use with lists as well. These include adding items to a list, removing items from a list, sorting the list, or reversing the list. Okay, we can do all of these things to our list. We can also combine lists together. We can extend the list by adding another list to the end. Okay, we can check whether or not an item is in a list. So we can use an if-then setup type arrangement. We'll talk about that here in a moment. And we can also return the length of the list as a function. Okay, and I'll talk about that here in just a second. Okay, let's go through and kind of run through examples of each of these. Okay, so let's say that we want to add Bobby to our attendees list up here. Let's actually go ahead and delete some of, that's fine. Get these out of the way so we can see our list. Let's delete all of this, so we'll just work off the big one here. Okay, so we want to add Bobby to our list here. Okay, and what I've done is said, okay, attendees list dot append, and in the parentheses added the name that I want to add to the list. So now when I print this list, it is going to show me all of the names up here, like same, plus Bobby. Okay, but let's say that we now don't like Bobby. Okay, we're going to say we want to get rid of Bobby. Okay, so we can say attendees list dot remove, and we're going to say Bobby was uninvited to our list or to our event, and we can print this list again. And so now you can see he's no longer there. Okay, it also doesn't have to be the first thing. We can remove something from the middle if we wanted to. Let's say we wanted to remove Paul. That would remove all of the Pauls from our list. Okay. You can see, or it removes the first one. We'd have to remove the second one, run it again, and print it again. And see, we did that again, and they're all gone. Okay. I'm going to run this up here, and now what you'll see is that Paul's back in our data set. And I'll Bobby. Okay. We also want to be able to sort our list. Okay, so we're going to say attendees list dot sort, and then we are going to print attendees list. Okay, and this is going to print it alphabetically. Okay, we can also reverse it. Let's put this right here. Attendees list, say reverse, and print it out, and it goes the opposite way. Okay, so we have sort, which is going to sort A to Z, or 1 to 100. Okay, it's going to sort biggest to smallest, or we can use reverse instead of sort to kind of sort the other way. Okay, So again, these are methods that we can use, and we run the methods up here, and then we pass it through the function down here. Some of these you can put inside of this, although it does not necessarily like it, okay? It's better to do it like this, and then to print it. So yesterday when we did some of the methods, or last week when we did some of the methods, we put the methods inside the print function. It doesn't necessarily like it with lists, okay? So we want to do the thing, do the method, and then print it out, okay? We can combine lists if we want to. So I could say big list is equal to attendees list plus attendees lists. Monday we'll do small, and then let's print out big list. And you can see now we have a bunch of other things on here as well. Okay, actually let's change this to 2. So you can see it has a whole bunch of different things. There's that numbers and the other lists, but we haven't said put list inside of list, which we can do. What we've said is, hey, take our list, take this other list, and merge them together. Okay. Instead of saying append is for one item. If we want to add multiple items, we could do that as well. So we can say attendees list dot extend is the method we're going to use, and then we put multiple names in here. We could say Paul, and then we could say John, and then we can say Mary, okay, and what we've done is now, made a mistake. It takes one exact argument. Oh, blast. Okay, well, I made a mistake. What did I do wrong? You know what? That is unfortunate. I know what I did wrong. I forgot to add the brackets. There we go. Okay, so what I've done is basically taken a list, made the list here, added the list into this other list. There you go. Sorry about that. Okay, it's going to happen a lot this season. This school year. We can also check if something is in our lists, and that is when we get into if functions, which we'll talk a lot about more, but I just want to demonstrate one. So check if, let's say Paul, if Paul in attendee list, we say print Paul is at the party, or Paul is invited. How about that? And then we're going to say else and print Paul was not invited. Okay. On that and say Paul is invited. So what it's doing is we're saying if Paul, so if any data point is in our data container, do this. And you'll say there's a colon there. We're going to talk a lot more about this, but just as an example, there's a colon there. If Paul is there, we're going to print this. If he is not there, this is the else, Paul was not invited. So if Paul is invited, yes. If not, or we can change it. Let's change it to they. And we can try another name, like let's say Henry. They was not invited. That's great English. They were not invited. Okay. So that is how we do some of this if statements. We can also do it other ways. I'm not going to get too deep into that. We'll talk about that more. The other function I want to talk about is our length function. Okay, so we'll say attendees length is equal to length of attendees list. Nope. Print. Nope. We won't print it with a capital. We won't print attendees length. And so this function allows us to count how many things are in our list. Okay, and we can see from our attendees list here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And so this counts every entry inside of that list. Okay, so those are some of the basic tools and methods that we'll get through. There's a lot of other stuff that we can do. This is just scratching the surface, letting you kind of get things hands dirty and figure stuff out. Okay, so we talked about most of these. Let's talk about now sets. Okay, sets are an unordered collection of distinct objects. Okay, so they are like lists in that way, right? Well, they're not necessarily as like that. Okay, let me start over. They are a list of distinct objects. Okay, they are unordered. Okay, which means that we cannot use an index function to tell individual locations like we would with lists. It's a little bit different. Okay, we're going to use braces to create these sets, or we're going to use a set function to turn things into sets. Okay, so we really like it for checking membership. Okay, so if we have a long list of things and we want to check if there are duplicates or create a list that has just unique values, this is what we're going to use. Other than that, we're not going to use sets too much. Okay, let's say, for example, I have a list of all of my students, right? And in that list, I have a list of all of your student ID numbers. Okay? It might make sense for me to turn that into a set so that there are no duplicate student ID numbers, right? That way I can't create duplicate student ID numbers. I can't do anything like that. Okay, so what are the major differences between sets and lists? Lists are ordered, okay, which means that order of elements is maintained to some degree. Okay, we can reference those points. Sets are not ordered in any particular way. So some of the functions that we talked about don't apply, or some of the methods we talked about don't apply. We can have duplicate entries in our lists, okay? Sets, we cannot have duplicate entries, which make them a unique, fun tool for making sure that everything is the same, okay, or making sure that we only have one of everything. Lists are mutable, which means we can add things in and out. Sets are kind of mutable, and we'll talk about that a little bit more on Wednesday. Let's just give you some examples of a set before we head out. So we have a lot of duplicates in our list here, okay? And we want to create a set from this, and we're going to say attendees, say set. And we're going to set this equal to the set function of attendees list. Okay, and then we're going to print out attendees set. And what we have now is, here's our first, actually let's do this too. Actually, I don't know if those will, I think it won't like this, but let's try it. Of these set. I might get an error from that. Oh, there it goes. Okay. Some of these functions and size functions don't like it. Length is okay. 9. So we have, instead of 13 items, we have 9. This has removed all of the duplicates that we had before. Okay. Can I sort this? Let's see. Set. And dot sort print no. Why not? Any reasons? Yeah, can't do this because the list is unordered, okay? The things that are in there, and there is really can't kind of go in and say, do anything about that. Let's say I just want to print the first one in our list here. Can't do that either, okay? So we don't have an index available in set, okay? Now, if I wanted to change this back into a list, I could. Okay, there's nothing that says I can't do that. Oh, sorry. Nothing saying that I can't switch it back over. It doesn't like it, obviously, because I have to change it before I do that. But I could do that, right? I could say, new is equal to list of attendees set, and then I could print out attendee set in position 1. Oh, it doesn't like it. Okay, well, I'll work on that. I think I'm missing a letter or something somewhere. Again, this is what we're going to have this semester, is just me remembering all of the nuances here. So don't get discouraged. But that's our big thing with sets. We can also create new sets. We can say teacher set is equal to, we'll use our braces here, and we'll say Dr. Baxter, Way, and let's just go ahead and try Dr. Way twice on here and see what happens. Okay, and then I can print out teacher set. What happens is that one of the entries gets deleted. Okay, it's never going to be able to take multiple of the same kind. It's always going to be unique values. Okay. All right, so that is the code for, or at least the practice for the run through for today. We'll go ahead and stop there, and we'll go over all of this on Wednesday and try practice code and some of the homework as well. Okay, so just remember, lists, we can sort, we can order, we can index, use an index to find out where they are. They are extremely flexible. We can use methods on them. We can add things, delete things. Sets we can do a lot less with, right, in terms of what we can do, as you've seen on here. But we are not allowed to put in duplicates. That's the big difference. Okay, so let's work on the homework on Wednesday, or the lab on Wednesday, and we'll see you in class. Bye.